features of Oracle. Here at Oracle, we have live classes to elevate your learning experience. Then you have recorded classes so that you can access your subjects anytime, anywhere through recorded sessions. Then there are notes available ultimate in the form of ultimate comprehensive books based on the latest syllabus. They also have question banks. Then you have MCQs to cater to everyone's need, beginning from the beginner's level to the expert level. Then apart from the academic support, here at Oracle, we also provide you with personalized counseling sessions. So you can anytime book a slot with us for that extra guidance. It'll be more like a therapy session, very personalized, one-to-one. Then apart from that, we have 3 different subscription plans at Oracle. That is basic, standard, and premium. The basic is for 3 months and it will cost you around 15,000. The standard is for 6 months and will cost you for 30,000, and the premium plan is for 12 months, which you can be availed for 50,000. By using my promo code as displayed here on the screen, you can get an additional 20% off. Then briefly introducing you to our new internal exam marathon series. This series has been specifically curated and oriented for your university exams, which are approaching in a while. So we will be focusing on rapid revision of all the important topics. Then apart from that, volatile facts will also be covered. There will be quick revision with multiple choice questions so that we can assure you top-notch grades in your exams. Okay, so without wasting much time, let's start our today's class, that is chylomicron and its metabolism. Lipoproteins, actually not just chylomicron, but all the lipoproteins and its metabolism. Okay, so beginning with a brief introduction, the dietary fat and endogenously synthesized lipids must be transported between various tissues and organs for their utilization and storage. So they're saying that whatever lipids you're consuming through either through diet or whatever has been synthesized endogenously, that is being synthesized by your body, it needs to be transported to various organs so that it can be utilized and stored. But since we all know that lipids, they are insoluble in water, so it is difficult for it to be carried in aqueous blood plasma, because your blood plasma is basically, it is aqueous. And your lipids, they are non-polar, and whereas your water, it is polar, so the non-polar will not dissolve in polar, so it is very difficult for the lipids to be carried through the blood plasma. So for that matter, for its transportation, what happens is that the lipids, they are complexed with proteins. Okay, so the proteins are going to act as carriers for them, and they'll be transported in the form of lipoproteins. So what are lipoproteins? When you complex lipids with proteins, so you end up with a structure which is known as lipoproteins. Now these lipoproteins, they can be transported in the blood. So the protein part of lipoprotein is known as apolipoprotein. Okay. So what are we saying? That in order to transport lipids in our body, we are complexing it with proteins. So the structure, the resultant structure is known as lipoprotein. And in this lipoprotein, the protein part is called as apolipoprotein. So that was a brief introduction to lipoproteins, that what are lipoproteins. Now let's talk about the structure of lipoprotein. So this lipoprotein structure, it consists of 3 layers. What are those 3 layers? The inner core, the second layer, and the third layer. Now it is something like this. This is your inner core. It is followed by a second layer and then a third layer. Okay. So in the inner core, what do you have? You have hydrophobic lipids. Hydrophobic. What is hydrophobic? Something which hates water. Okay. So hydrophobic is non-polar. That is, do not have any charge. Okay, they are non-polar. So anything that is non-polar, it will be hydrophobic. They hate water, so they are going to be present inside the core, because in our body, the majority of the medium is aqueous medium. Okay, the blood plasma, it is all aqueous. So for that, and since it is hydrophobic, it will be present inside the core. And what are they? They are triacyl glycerol and your cholesterol esters. Remember when we were talking about cholesterol structure, I told you that your cholesterol is Why is cholesterol amphipathic? Because remember, I told you that it has a steroid nucleus, four fused rings. So the ring A at carbon 3, it had a hydroxyl, if you remember. So that hydroxyl group was providing it some polarity. Okay, and then there was also a hydrophobic chain at the carbon 17 of D ring, if you remember, if you recollect. Okay, so therefore your cholesterol becomes amphipathic. But your cholesterol ester, when it forms an ester linkage with fatty acid, and that is the hydroxyl at third position, is engaged in an ester linkage with fatty acid. So the hydroxyl that was providing it polarity is lost. So your cholesterol ester is hydrophobic. Similarly, your triacyl glycerol, okay? When your glycerol, which is an alcohol, it engages with fatty acids to form triacyl glycerol via ester linkages. This triacyl glycerol is hydrophobic, okay? So the inner core consists of hydrophobic lipids, which are your fats and your cholesterol esters. Now the second layer, it consists of amphipathic lipids, okay? Second layer consists of amphipathic lipids. Now what are they? Amphipathic is compounds having both polar and non-polar portions in their structure. They are amphipathic. Amphipathic is compounds having both polar and non-polar portions in their structure. So that is your cholesterol, like I just described, and your phospholipids. They are amphipathic. So they are present in the second layer. And the third layer, it consists of proteins. Now these proteins can either be peripheral proteins or integral proteins. Example is ApoB100, which is an integral protein. So this is a diagram. You can understand this with the help of a diagram. You can see this is your inner core. The inner core consisting of triacyl glycerol and cholesterol ester. So this is the inner core, and this consists of triacyl and cholesterol ester. This is followed by this second layer, which consists of what? Your second layer consists of amphipathic lipids, which is cholesterol and phospholipids. Okay, so this is your second layer. And the third layer, the outermost layer, it consists of proteins, peripheral proteins or integral proteins. Your peripheral protein like ApoC and integral protein like ApoB100. So peripheral protein is that is only present on the periphery, as you can see. It is only present on the periphery. And integral proteins, they are going a little deep than just being present in the periphery. You can see it is going deeper than the peripheral surface. Okay, so those are your integral proteins. So that was about the structure of lipoprotein. This is another view, a diagram of chylomicron. You can see these are your integral proteins. Then you have phospholipids here and cholesterols in the second layer, and this is the core, okay, which is consisting of triglycerides and your cholesterol esters. Now let's talk about different type of lipoproteins. So what are the different types of lipoproteins that you have? Chylomicrons, very low density lipoproteins, low density lipoproteins, intermediate density lipoprotein, and high density lipoprotein. So they have actually been arranged in decreasing size and increasing density. Okay, so that means decreasing size. So size is decreasing in this order, which means your chylomicrons are the largest in size, and your high density lipoprotein, which is HDL, they are the smallest in size. But They are the maximum dense. Okay, the name itself says high density lipoprotein. So your HDL, they have the highest density, and your chylomicrons, they have the lowest density. See, in this another diagram, you can appreciate that the density is increasing from 0.95 gram per ml to 1.20 gram per ml, from chylomicrons to HDL. But you can see the size is decreasing. The chylomicrons are the largest in size, and your high density lipoprotein, they are the smallest in size. Okay. Now let's take each of the lipoproteins one by one. I'll introduce you to some of the key facts about each of the lipoproteins. So beginning with chylomicrons. Okay, so chylomicrons, they're lipoproteins. They are those lipoproteins which carry exogenous or dietary tag from intestine to peripheral organs. Okay, so your chylomicrons, they are involved in transport of your dietary or exogenous tag, that is whatever you're having from outside, from the intestine to the peripheral organs. Okay, and they have the maximum size, and maximum size means maximum lipid content and least protein content. Okay, now more the protein content, more is the density. So they have least protein content, that means they have the least density. Okay, they have maximum lipid and least protein, which means they have least density, and your density depends upon protein content. So more the protein, more is the density. So since they have least protein, so they are the least dense, your chylomicrons. It has maximum tag. So the lipid that is maximally present in chylomicron is tag. This can also form one of the MCQs. That is, it can be asked like which of the following lipids is maximally present in chylomicrons, and your options might be triacylglycerol, phospholipid, etc. So you're going to mark tags, okay?
சூடா இருக்க ஒரு இந்த அளவுக்கு இருக்காது பரவாயில்ல.
Okay. So lipid that is maximally present in chylomicrons is tag. Then apolipoprotein present in chylomicrons are ApoB48, ApoC, and ApoE. So that was briefly introducing you to chylomicrons. That is, so chylomicrons, they are involved in the transport of exogenous or dietary tag from the intestine to the peripheral organs, and they have the maximum size and the least density, and your density depends upon the protein content. So they have the least protein content, therefore they have the least density. And also the apolipoproteins present in chylomicron, they are ApoB48, ApoC, and ApoE. Now moving on to very low density lipoprotein, also known as VLDL. So VLDL, they are assembled in the liver. They carry endogenous tag, okay? Now that's the difference. That is that triacylglycerol that is being synthesized in the body, okay, from the liver to the peripheral organs for energy needs. Now, apolipoprotein present in VLDL is ApoB100, ApoC, and ApoE. So your chylomicrons, they were carrying exogenous tag, and your VLDL, they are carrying endogenous tag. Low density lipoprotein, that is LDL. It is formed from VLDL majorly, but a small part of LDL is directly released from liver. VLDL is initially converted to ideal, that is intermediate density lipoprotein, and later to low density lipoprotein. Okay, this is known as lipoprotein cascade pathway. We'll talk about this later in the lecture in detail. As of now, just know that your VLDL, it first changes to ideal, and then that ideal, it changes to LDL. And this is known as lipoprotein cascade pathway. So majorly, this is how you're getting your LDL, but some of it is directly released from the liver. Now, LDL particles contain much less stack than their VLDL predecessors and have a high concentration of cholesterol and cholesterol esters. This point will also become very clear when we talk about the LDL metabolism later in the lecture. And cholesterol present in LDL is called bad cholesterol. I'm sure all of you by now know that LDL is bad cholesterol, but why is it a bad cholesterol? We'll just get to know. And apolipoprotein present in LDL is ApoB100 only. Okay, so LDL contains only single apolipoprotein, that is ApoB100. So LDL contains single apolipoprotein, that is B100. High density lipoprotein. It is synthesized time it transports cholesterol from peripheral tissues to liver. So your HDL is transporting cholesterol from peripheral tissues to the liver. So this is considered as good cholesterol, whereas your LDL, it was transporting it from the liver to the periphery. So that was known as bad cholesterol. And when we talk about the metabolism, you will understand the reason behind it, the concept. Now, HDL has maximum protein content. So that is, it has maximum apoprotein because that is the protein that is present in lipoproteins. Okay, so HDL has maximum protein content and least lipid content. Therefore, it has maximum density because more the protein, more is the density. So your HDL, they have maximum protein, so they have maximum density and they have the least size. So they are smallest in size. It serves as a plasma reservoir for ApoC and ApoE. So you see why it has a maximum protein because it is serving as a reservoir for your apoprotein C and apoprotein E. So they have the maximum protein and therefore they have maximum density. And your apolipoprotein present is ApoA1 in HDL. Now, HDL also has two enzyme activities, that is LCAT, lecithin cholesterol acyl transferase activity, and CETP, that is cholesterol ester transfer protein. So these are the two enzymatic activities that are present in HDL. So I briefly introduced you to all the lipoproteins, that is chylomicron, VLDL, LDL, and HDL. So after we've spoken about their metabolism, you will actually be able to memorize these points on your own, okay? Because once you study the metabolism in a sequential manner, it's like a storyline form in flow. So all these points will automatically fall into place. You will not have to memorize any of these, okay? Now let's see what are these two enzyme activities. What are the actions of these two activities? So talking about lecithin cholesterol acyl transferase first, it is involved in conversion of cholesterol to cholesterol ester. So your LCAT is converting cholesterol into cholesterol ester. How? We all know that cholesterol will form cholesterol ester. How? When its hydroxyl group form ester linkages with fatty acid. Now, where is this fatty acid coming from? This fatty acid is given by lecithin. Okay, so the fatty acid of lecithin is given to cholesterol, and what forms? It forms cholesterol ester. And this lecithin, after it gives it fatty acid, it is known as lysolecithin. So after the fatty acid is removed from lecithin, it is known as lysolecithin. Okay. So that was about LCAT. That is, it converts cholesterol into cholesterol ester. So for that, it needs fatty acid and avoided by lecithin. And lecithin itself, now talking about CEPT, it converts cholesterol, it transfers cholesterol esters from HDL to other lipoproteins and in turn receives tags from them. Okay, so you can see in this diagram that this is an HDL being represented. So cholesterol esters from HDL, they are being transferred to other lipoproteins that can be LDL, VLDL, IDL. And in turn, what do they receive from them? They receive triacyl glycerols in return from them. So this is brought about by this enzyme known as cholesterol ester transfer protein. Okay, why? Because it transfers cholesterol ester from HDL to other lipoproteins and in turn receives tag from them. So that was talking about the two enzyme activities which are present in HDL. Okay, now let's talk about the metabolism of lipoprotein. So beginning with the metabolism of chylomicron. So particle released from intestinal mucosal cell is known as nascent chylomicron, which has only one apolipoprotein, that is ApoB48, and it carries dietary tag and cholesterol. So as we know that your chylomicrons, they are involved in the transport of dietary tag. Okay, so whatever tags you've had exogenously, they will be present in your intestine. So they are assembled in the chylomicron. So your intestinal mucosal cells, let's understand this with the help of the diagram. So your intestinal mucosal cells, they secrete what? They secrete nascent tag-rich chylomicrons. Okay, so the chylomicrons that are produced by the intestinal mucosal cells, initially they're not mature chylomicrons. They are secreted in nascent form and they are rich in tag, exogenous tag, okay? And they only have one apolipoprotein, that is B48. So this is your nascent chylomicron, you can see here, and this is rich in tag, and it has only one apolipoprotein, that is ApoB48, and this is secreted by the intestinal mucosal cells. Now what happens after it is being released, after the nascent chylomicron has been released by the intestinal cell, it acquires ApoC2 and ApoE. And where do these ApoC2 and ApoE come from? They are being given by HDL. As we studied that HDL is the reservoir for ApoC2 and ApoE. And now this nascent chylomicron, after receiving ApoC2 and ApoE, it becomes mature chylomicron. Okay, so this is mature chylomicron. Now you can see this mature chylomicron, it has exogenous tag and it has three apolipoprotein, that is B48, C2 and ApoE. Now this is what is known as mature chylomicron. So nascent chylomicron acquires two apolipoprotein from the blood, that is ApoC and ApoE, and become mature chylomicron. Now this mature chylomicron, it will pass through the capillaries that line the peripheral organs like your heart, skeletal muscle, and adipose tissue. Now you see this mature chylomicron, it is going to pass through capillaries that are lining your peripheral organs. So it's going to be, if I make a simpler diagram, it's going to look like this. Suppose this is your mature chylomicron. This mature chylomicron, it is going to pass through capillaries which are lining your peripheral organs. And in the capillary, what is present is present lipoprotein lipase. Lipoprotein lipase is present, okay? And these capillaries are lining your peripheral organs. Let's suppose this is some peripheral organ. Okay, so your lipoprotein lipase, it is present in vascular endothelium of capillaries lining peripheral organs. Present in vascular endothelium of capillaries lining peripheral organs. Okay. So now you can see this mature chylomicron, it is going to pass through these capillaries. And in the capillary endothelium, what is present? You have lipoprotein lipase is present. Okay. Now this lipoprotein lipase, it is activated by just a second, hold on. Yeah, okay. So you see, just passing here to the capillaries, and in the capillaries, you have endothelium, you have this lipoprotein lipase present. Now, this lipoprotein lipase, it is activated by ApoC2. ApoC2, you can see here, it was present in mature chylomicron. So this ApoC2, it activates the lipoprotein lipase present in the vascular endothelium of the capillaries, and as a result of which, this lipoprotein lipase, it is going to hydrolyze the dietary tag that was present in chylomicron into free fatty acids and cholesterol. Now, this cholesterol will go to the liver, and free fatty acid is taken up by peripheral organs. Okay. Now, what happens? You are left with what is left now after 90% of the tag has been hydrolyzed. You are whatever structure is left, it is known as remnant chylomicron. Okay, after it loses C2 to HDL, and almost 90% of the tag has been hydrolyzed and C2 has been returned to HDL. What is left is known as remnant chylomicron. So your remnant chylomicron will be rich in cholesterol esters, okay, and it will only have ApoE and ApoB48. Now what happens? This cholesterol ester rich chylomicron, which is known as the remnant chylomicron, it binds through ApoE to specific receptors on the liver and are endocytosed. That is, in the liver or on the liver surface, there are receptors for ApoE. Okay, so this ApoE on the remnant chylomicron, it is going to act as a ligand for the receptors that are present in liver, and it will be internalized or endocytosed, which is internalized. Okay, that is this process of uptake of remnant chylomicron mediated by the receptors. It is known as receptor mediated endocytosis. Okay, I'll write this for you. Okay. This process of uptake of remnant chylomicron by the receptors is known as receptor mediated endocytosis. Okay, so it is rapidly removed from the circulation. That is, the remnant chylomicron is rapidly removed from the circulation by the liver. So that was talking about the metabolism of chylomicron. I'll recapitulate this for you briefly so that it becomes more clear. So what is happening? Actually, I'll take this in the form of a flow diagram. Okay, in exam, if you're not it's not necessary for you to be like so artistic and draw these diagrams. You can simply write it in words in the form of a flow chart. Okay, rather than writing paragraphs, avoid writing paragraphs, or if you do at all, then underline the keywords. It's going to fetch you more marks. Otherwise, in science medical school, it is very much preferred if you write your answers in flow chart forms. Okay, so your intestinal mucosal cells, intestinal mucosal cells, what are they going to secrete? They are going to secrete nascent chylomicron. So nascent chylomicron, it is rich in Your nascent chylomicron is rich in dietary tag, and it only has one apolipoprotein, which is ApoB100. ApoB48, sorry, ApoB48 present. Okay. Now this nascent chylomicron, it changes to mature chylomicron. How? By acquiring ApoC and E from HDL. Now this mature chylomicron, it is going to circulate through capillaries lining peripheral organs. So it passes through capillaries lining peripheral organs. And in the capillary endothelium, what is present? Lipoprotein lipase is present. Lipoprotein lipase present in vascular endothelium of capillaries. Okay, so by the action of lipoprotein lipase, जो tags by the action of lipoprotein lipase, it will form what? Free fatty acid plus glycerol. Your fatty acids, they're taken up by peripheral organs, and your glycerol, it goes to the liver. Now, what is left is your remnant chylomicron, which will be taken up by liver by receptor mediated endocytosis. So this flowchart is briefly for chylomicron metabolism. So I have made this for chylomicron. You can do this for rest of all the other lipoproteins. Okay. So now your remnant chylomicron, after most of the tag has been hydrolyzed and ApoC2 has been given to HDL, your mature chylomicron changes into remnant chylomicron. This remnant chylomicron is taken up by the liver by a process known as receptor-mediated endocytosis. And how? That is, your liver, they have receptors for ApoE2 that is present on the surface of remnant chylomicron. Okay, so ApoE2 is going to act as a ligand for the receptors present on liver. So that was about chylomicron metabolism. Now moving on to LDL, VLDL and LDL metabolism. And also, I'd like to tell you an important, interesting fact. Yesterday, we spoke about GAGs, okay? And I told you that your heparin sulfate is present in basement membranes. So heparin sulfate is that GAG which is involved in the anchorage of your lipoprotein lipase to vascular endothelium. Here, this lipoprotein lipase, it is anchored to the vascular endothelium with the help of heparin sulfate. Heparin sulfate. Okay, this GAG, it is involved in anchorage. Anchors lipoprotein lipase to vascular endothelium. So this can form an important MCQ, that which of the following GAG is involved in the anchorage of lipoprotein lipase to the vascular endothelium, and your options might be heparin sulfate, conductin sulfase, dermatan sulfate, heparin and all. So you're going to mark heparin sulfate. Okay. Now moving on to VLDL and LDL metabolism. So your VLDL, it is being secreted by liver. So your liver is again going to secrete nascent VLDL, and this nascent VLDL, it is rich in tag, but this tag is endogenous tag, and it only has ApoB100 as the lipoprotein, apolipoprotein present. So your liver, it secretes nascent VLDL, and this nascent VLDL, it is rich in endogenous tag, and it only has ApoB100. Now what happens? This nascent VLDL, it is going to take ApoC2 and ApoE from HDL and forms what? It forms VLDL. Now this VLDL, it is again going to circulate or pass through capillaries lining your peripheral organs. Now again in the capillary endothelium, what is present? Your lipoprotein lipase is present, which will be activated by ApoC2, and this lipoprotein lipase, it is going to degrade your TAG into free fatty acids and glycerol. Your glycerol is taken up by the liver, and your free fatty acids, they are taken up by the peripheral organs. So this free fatty acid that is taken up by the peripheral organs, it is basically what? It is the endogenous tags, okay, the endogenous lipids that were being synthesized, because your PLDL, they carry endogenous tag from liver to the peripheral organs. So you see how from the liver, your endogenous tag has been brought to the peripheral organs, okay. So VLDL, they carry endogenous tag from liver to peripheral organs. Now, this remnant VLDL is known as IDL, okay? So, your VLDL, it becomes remnant VLDL, which is known as IDL, okay? Now, this ideal, it has two fates, two different fates are possible for this ideal. First, that it can be taken up by the liver by receptor-mediated endocytosis, as we just discussed, and the ligand will be ApoE. So, ApoE is going to act as the ligand, and the receptors are present on the liver, and via receptor-mediated endocytosis, this remnant VLDL or ideal will be taken up. And the other fate of this ideal is that it loses more tag, and ApoC and E are liberated, and they go back to HDL, and after this, this ideal is converted into LDL. Okay, so the only apolipoprotein that is present is B100, and this way the ideal has transformed into LDL. So firstly, the VLDL, it changes into ideal, and then that ideal changes into LDL. So this is what is known as lipoprotein cascade pathway. I'll just recapitulate it once again. That is, your VLDL, your remnant VLDL is known as ideal. Now, this ideal can have two different fates are possible, okay? Two different fates. Okay. First fate is that it can be taken up by the liver, taken up by liver by receptor mediated endocytosis. And for this, your ApoE is going to act as ligand. And the receptors are present on liver. Okay, and the other fate is that it loses more tag. So your tag content decrease. ApoC and E are liberated, and your ideal changes into LDL. And the only apolipoprotein present is ApoB100 present. Okay, so you see your VLDL first changes into ideal, and then that ideal changes into LDL, and this is known as lipoprotein cascade pathway. Okay, now let's see what happens. So you can see ApoC2 and ApoE, they are returned back to the HDL, and what are you left with? You are only left with ApoB100, and this is known as LDL. Now this LDL again has two different fates, okay? That is 70% of the LDL. 70% of the LDL is taken up by the liver, again by receptor-mediated endocytosis, and the ligand is ApoB100 is going to act as the ligand, and the receptor for this ApoB100 are present on the liver surface, okay? And the other fate is that 30% of this is taken up by extrahepatic tissue. 30% of LDL is taken up by extrahepatic tissue. So 30% of the LDL is taken up by extrahepatic tissue, and this 30% of LDL that is taken up by extrahepatic tissue, this makes it the bad cholesterol. This 30% is going to make it the bad cholesterol, okay? As it can get deposited in cerebral or coronary vessels and lead to plaque formation. So now you know why your LDL is known as bad cholesterol. Let me just quickly recapitulate this for you. So your liver, it secretes nascent VLDL, which is rich in endogenously synthesized lipids, and it only has ApoB100. Then after being released as nascent VLDL, it acquires ApoC2 and ApoE from HDL, and it becomes mature VLDL. Now this passes through the capillaries lining the peripheral organs, where it activates the ApoC2 present in it, activates the lipoprotein lipase in the vascular endothelium of capillaries, and then they tag the endogenous tag, it is degraded into free fatty acids and cholesterol. Now, what is left is known as remnant VLDL, and it's also known as intermediate density lipoprotein or IDL. Now, this IDL has two fates. That is, one, it can be taken up by the liver, and the second is that it loses tag. It also liberates ApoC and E, and it only is left with ApoB100, then it is called low density lipoprotein or LDL. So your VLDL, it changes into IDL, and then that IDL changes into LDL. This is known as the lipoprotein cascade pathway. Now this LDL again has two different fates. One is that 70% of this is taken up by the liver by receptor mediated endocytosis, and the ligand for this is ApoB100. And the 30%, the rest 30% is taken up by extrahepatic tissue. Again, the ligand for this is ApoB100. This 30% that is taken up by extrahepatic organs, this makes your LDL the bad cholesterol, as it can get deposited in the coronary or the cerebral vessels, leading to plaque formation. Now, let's talk about HDL metabolism. So your HDL, it is involved in reverse cholesterol transport. Okay. The factors which help HDL to facilitate reverse cholesterol transport are LCAT, ApoA1 present in HDL activates LCAT activity. So we all know that LCAT, that is lecithin cholesterol acyl transferase activity, was present. Then we also know that apoprotein A1 was present in HDL. And then there are transporters. Those transporters, they are involved in transport of cholesterol and cholesterol esters from peripheral organs to HDL. So this is your peripheral organ. This diagram you can see here. It can be your any peripheral organ, and these are the transporters that we are talking about. And these these transporters, they are responsible for the transport of cholesterol and cholesterol esters from the peripheral organs to the HDL. We will see how. So what is happening? Your HDL, it is secreted both from the intestine and the liver. Okay, so the intestine, it secretes discoidal HDL. Okay, this nascent HDL, it is known as discoidal HDL. Okay, your nascent HDL is known as discoidal HDL. Is discoidal. Why? Because it has cholesterol and phospholipids, and they are amphipathic lipids, so they cannot form a spherical structure. Okay, they can only form a bilayer kind of a structure. Okay, so therefore it is present in the form of a discoidal shape. Okay, so your nascent, your intestine and your liver, they secrete nascent HDL, which is discoidal in shape, as it is rich in cholesterol and phospholipids. Okay, this is rich in cholesterol and phospholipids, and since cholesterol and phospholipids, they're amphipathic, they cannot form a anything which is amphipathic, it cannot form a spherical structure. Okay, they are always present like the plasma membrane, they are present in the form of a bilayer. So this is discoidal. Now what happens? Your ApoA1, it activates the LCAT activity. So ApoA1, it activates, you can see the ApoA1.
Have stopped the recording, ma'am. Device got disconnected. You can connect it.
Yeah.
Ma'am, what is happening?
My Wi-Fi is not being detected.
Okay.
Wait, I'll quickly use my
This
hotspot.
device connected properly only. Second device is not connecting.
Yeah. It's literally the same Wi-Fi. Mhm.
Yeah, connected, ma'am. You can share the screen now, ma'am.
Is the screen visible?
Has started screen sharing, ma'am. It is still not visible. We'll see. Loading anything. Ma'am, one device got connected. Second device need to connect. Ma'am, ma'am, can you hear my voice? Ma'am, can you hear me? Ma'am, may I know the status, ma'am? One device got connected. What exactly happening?
Hello?
Ma'am, ma'am, this device got connected. The second device need to get connected, ma'am.
Hello?
Yes, ma'am. Ma'am, is my voice audible?
Can you just make me the host from my mobile? Yeah, yeah. Can you just make me the host from the mobile? I'll share my mobile screen because only 5 minutes of it is left now. I
Yes,
don't need
yes,
to
sir.
write it.
Acha, you want me to make co-host, ma'am?
Yeah, from my
Co-host, right?
mobile.
Yeah, yeah. Okay,
But
okay.
please,
Please
my
log in.
mobile is connected.
Okay.
Yeah, done.
Mm, okay, 1 second, ma'am. Okay. To this only, I have given a co-host permission, ma'am, to this device only.
Okay. Yeah, yeah. Is it visible? My screen.
No, ma'am, not visible.
No.
Not visible, ma'am.
Not visible.
Not visible.
Is it visible now?
No,
No. Is it visible now?
able to
Hello?
see the screen now, ma'am. Will you continue from here,
Is
ma'am?
it visible?
Yes, ma'am. Can you
Okay,
can
I'll
you also
quickly
turn on
take
the
this
camera,
into.
ma'am?
Yeah, yeah.
Can you please turn
I'm
on?
using the mobile actually.
Yeah,
Okay,
yeah,
wait.
understand, ma'am.
Is it a video visible?
Yes, ma'am, visible.
Okay, okay. I'll quickly take it.
Ma'am, please continue.
Okay. So there was some disturbance. Sorry for the inconvenience. So we were talking about HDL metabolism. So in HDL metabolism, I told you that the intestine and the liver both secrete. Yeah, it started. Yeah. So in HDL metabolism, HDL, nascent HDL is secreted both from the intestine and the liver in the form of discoidal HDL. It is discoidal because the nascent HDL is rich in your cholesterol and phospholipids, which are amphipathic lipids. Okay, so they are present in the they cannot form structures, and they can only be present in the discoidal HDL. It is going to activate LCAT. Now, by the action of LCAT, what will happen? Your cholesterol will be so there will be in
Sarath sir.
yeah. So they will be internalized. Your LCAT will convert present in the discoidal HDL into cholesterol phobic. They will be internalized, and as a result, you will end up with spherical HDL3. Now, the spherical HDL3, it is going to receive cholesterol and cholesterol esters from peripheral organs via this transporter that have been shown. Okay. Now, it receives more and more cholesterol, and by the activity of LCAT, that cholesterol is converted into cholesterol esters, and which are being internalized. So you have more and more space on the periphery. So by this, what happens to spherical HDL3? It is converted into spherical HDL2. Now, this spherical HDL2, it donates its cholesterol to the liver, and in the liver, this cholesterol is converted to bile acids and excreted. So, this cholesterol that is being excreted via the liver, it is basically the cholesterol that is coming from the peripheral tissue. So, in this way, your HDL, it is considered as a good cholesterol as it is involved in reverse cholesterol transfer, that is from the peripheral organs to the liver, and from the liver it is being excreted out. Okay, you can see this. There is this diagrammatic representation that how your liver, it forms VLDL, and then that VLDL is transformed into LDL, and then that LDL is to deliver cholesterol to the cells, so making it a bad cholesterol. But on the other hand, you can see from the peripheral organs, the HDL is to remove the excess cholesterol from the cells, and then this HDL, it acts as a truck, it acts as a transporter, and it transports the your cholesterol from the peripheral tissues of the cells to the liver, and in the liver they're excreted in the form of bile acids. So that is the reverse transport. Okay, so with this we come to the end of our class. Thank you for watching. If you have any queries, you can send them. Thank you.